Let's take a look at Chapter 5, Test Review. Let's see, 9 minutes. Okay, I'm ready to start. And going kind of slow right now. Well, just turned my computer on. I was kind of going kind of slow myself too. I just woke up from a nap. There, it's loading. Hopefully it doesn't take 90 minutes to load. And there, it's going a little faster. Waking up. Okay. Graph solution set of the following system of inequalities. So we got 4x plus 8y is less than or equal to 8. Let's start with that one. 4x plus 8y is less than or equal to 8. Different ways you can graph this. If you do points, then you can, and that might be easiest in terms of my math lab, but you can definitely plug in your calculator if you can get y by itself on the left side. But if I pick the x-intercept, for the x-intercept you always plug 0 into the other variable. And we pretend the inequality symbol is an equals. And so we'll plug 0 in for y. So we got 4x plus 8 times 0 is equal to 8. 8 times 0 drops away. We got 4x is equal to 8, or x is equal to 2. So our x-intercept is 2. For our y-intercept, again, we treat the inequality as an equals. So we got 4x plus 8y is equal to 8. And you always plug 0 into the other variable for your intercepts. So we're finding y-intercepts, so we'll plug 0 in for x. So I got 4 times 0 plus 8y is equal to 8. So we got 8y is equal to 8, or y is equal to 1. Okay, so we got x is equal to, y is equal to 1. I'm going to make this a little bigger. And x is equal to 2. So this is better to the line tool. Y is equal to 1, right there. Now the region shading tool is one we'll use next, and it will either shade down here or up here. And what you can do is you can pick a test point to see which one works. Well, if I come over here and pick the origin's almost your perfect test point to always use, unless your line goes through it. So we'll plug 0 in for x and 0 in for y. So we got 4 times 0 plus 8 times 0. And this is a question mark at this point. We're wondering if that's less than or equal to 8. Well, 4 times 0 is 0, 8 times 0 is 0, so we get 0 is less than or equal to 8, which is true. Since it's true, then we shade decide where the 0, 0 falls, which is over here. So I got my shading tool. And then I'll click this. Now, what's this one? Okay, make it dashed or so forth. This is a less than or equal to, so this is a solid line. So that one's good there. Okay, now let's worry about our other one. So let me save that and come back over here. We got 2x plus y is less than or equal to 10. Maybe I didn't want to shade that yet. I was going to shade them, see where they both have it in common. Okay, we'll see what happens. Again, I could find the x-intercept and y-intercept here. So we got 2x plus y, and we turn the inequality into an equals. And we're finding the x-intercept, so you always plug 0 into the other variable. So we got 2x plus 0 is equal to 10. 2x is equal to 10, or x is equal to 5. And for our y-intercept, Still working with 2x plus y is equal to 10. We're going to plug 0 in for x. So I got 2 times 0 plus y is equal to 10, or y is equal to 10. So x is 5, y is 10. Oh, there it is. X is 5. Let's use this. And y is 10. Right there. And this is a, what is this? This is a less than or equal to, so that should be a solid also. We go down to my shaded region tool, region shading tool, and a, what is this? Less than or equal to. If I were to pick my test point, I'll put TP for that. Put 0 in for x, so I got 2 times 0 plus 0 is less than or equal to 10, and this is a question mark. 2 times 0 is 0 plus 0 is 0, so we got 0 is less than or equal to 10. That's true, which means I shade the side where 0, 0 falls. Well, on my shading tool, I would shade this, and I would shade this. I'm not going to be able to show it very well on here. Interesting. Is that clear the whatever I've selected? Oh no, cancel that. Okay. If I press my delete. Delete. Well, unfortunately I can't show this very well. Well, anyway, where they're both would be shaded would be this region right here. And so I click save. Now to graph this, that would be our answer. Now let me show it on the calculator, because you really do have to understand that your answer is where they're both shaded. Okay. So we got 4x plus 8y is less than or equal to 8. And want to get y by itself. So take 4x to the right side. So we got 8y is less than or equal to negative 4x plus 8. Divide everything by 8. And we got this right here, which gives us y is less than or equal to negative 1/2 x plus 1. And it's a less than or equal to, which means we want a lower left-hand triangle. Okay, that's our first one. And we're going to put that in y1. Now our second one, we want to get y by itself also. So take 2x over. We got y is less than or equal to negative 2x plus 10. And it's a less than or equal to, so again we want a lower left-hand triangle. And this is going to be our second inequality we're going to work with. And we'll put that on y2. Okay. So go to y equals clear. I do negative 1 divided by 2 x plus 1. Now we'll go clear to the left until my flashing cursor is on this first slash here. You can't go too far. It doesn't wrap around or anything like that. So I just need to do some more here. There I am. Once I'm there, I want a lower left-hand triangle, so I'll press my enter 3 times. If you got one of the newer TID4 colors, you have to, a little box pops up and you have to choose that option. Now this one's going to be a lower left-hand triangle too, so let me go ahead and set it while I'm over here. Again, your cursor has to be on this first slash for you to change those. And then we got negative 2x plus 10. And then graph. Now there's our first there's our y1, and there's our y2. Now your answer is where they're both shaded, and you can see it a lot easier on here. And that's why I was trying to, I didn't realize my math lab didn't allow that. But that's what I was trying to demonstrate on here by shading this region and shading then the region that went with this line, and then your answer would be where they're both shaded. But anyway, that's how you get your answer. Now what's not so easy to see is this gives it to you really nice, but where's this cross on your x-axis and y-axis? In a regular classroom, I just have them sketch what they see here. But my math lab is a little bit more precise about that, so it doesn't allow you to just sketch where you see. Like if it went up to 2, it counted wrong. So what you're probably going to have to do is the best bet on this. So maybe I can find my tab, or there it is. Is use your old-fashioned techniques to get your intercepts or get some points. Or once you put this in here, go to your table. So if you do second table, then you can use some points here to plot. See, like here's 2, 0. That's a point I could have plot. And 0, 1. That's another point. Now for my y2, I could have done -3, 16, or well, that's probably too big. 0, 10, and 1, 8. So you can also do that. Now second mode, exit out of that. Okay, so let's go to our next problem. Okay, solve this system by the addition method. So we got x plus 5y. First I'll do it by the addition method, then I'll show you how to do it on the calculator. X plus 5y is equal to 13. 3x plus 2y is equal to 13. With the addition method, we want to add together the x's, the y's, and numbers, but we want one of the variables to be eliminated. If I add them together now, x plus 3x is 4x, 5y plus 2y is 7y, nothing gets eliminated. First off, these have to be different signs. So I'm going to multiply one of these equations by a negative. And then, an easy way to determine what to multiply the equation by is if I choose to eliminate the y's, then for my first equation, you look at the other number. I'm going to multiply it by 2. So I'll multiply this, and again, I have to have one of them as negative, so I might as well say that's a -2. And then for my second equation, I'm eliminating the y, so I look at the other number, which is 5, and I multiply that by 5. That technique will always work. It may not always be the smallest number, but that will work. -2 times x is -2x, -2 times 5y is -10y, and -2 times 13 is -26. 5 times 3 is 15x. 5 times 2 is 10y. 5 times 13 is 65. And now I want to add these equations. -2x plus 15x is 13x. -10y plus 10y drops away. -26 plus 65 is 39. Yeah, 39. So now the y's are gone, they're eliminated. So we got 13x is equal to 39, divide both sides by 13, and you get x is equal to 3. Now at this point, you want to take that x value and plug it back into one of your equations, doesn't matter which one, both of them give you the same answer. You choose the easiest one, what looks like the easiest one to you. First one, numbers looks smaller than x anyway. So we got x plus 5y is equal to 13. We just said that x is 3, so put 3 in for the x. So I got 3 plus 5y is equal to 13. Take 3 over. And I got 13 minus 3, which is 10. And then divide both sides by 2, and you get y is equal to 2. So our answer would be 3, 2. Okay, 3, 2. Now let's show it on the calculator. Much easier way, and I'd recommend doing it on the calculator, is in order to do it on the calculator, you have to have all of your variable terms on one side. So the x's and y's on one side, and numbers on the right side, the constant term. Now the x's have to be lined up, the y's have to be lined up, and numbers have to be lined up, which they are in this case. So we'll write down the matrix that goes along with this. We'll drop our x's, y's, and equals, keep the numbers in their signs. So I got 1, 5, 13, 3, 2, 13. Now we're going to go input that into our calculator. So I'll go to my matrix menu. I'll do second x to -1. That's actually your inverse button. Right arrow over to edit. Enter on A. Now it's asking us for the size of our matrix. Size is rows by columns. We got 2 rows and 3 columns in this problem. So do 2 enter, 3 enter. And then I'll do my numbers. 1 inner, 5 inner, 13 inner, 3 inner, 2 inner, and 13 inner. After you get your numbers input in, you do a second mode to exit out. And then we'll do second x negative 1 again. Go over to math, up arrow to RREF. Press enter on it. Make sure you choose one of 2 R's. Then we'll go back into our matrix menu, second x negative 1, enter on A, enter again. And we get 1, 0, 3, 0, 1, 2. Now 2 equations, 2 variables. Our first 2 by 2 square here should be a diagonal 1 zeros over else, which it is. So this is our x and this is our y. The order of your answers matches the order of your variables in the columns. So this was our x column and this is our y column. So we'd get the same answer, 3, 2. Okay. Let's see, next question. Solve it by the addition method. Let me start a new page. We've got 4x minus 2y equals negative 2. And 3x minus 7y is equal to 4. Okay, let's eliminate the y's again. Well, both of them are negative. One of them needs to be positive. So I'm going to multiply one of them by negative. And again, to figure out what to multiply by, for my first equation, I'll multiply it, if I'm going to eliminate the y's, I'll multiply by the other number, by the 7. And again, I have to throw a negative in there somewhere, so that's by a negative 7. And for this, the second equation, I multiply by the other number, which is a 2. Okay, so negative 7 times 4x is negative 28x. Negative 7 times negative 2y is 14y. Negative 7 times negative 2 is 14. 2 times 3 gives us 6x. 2 times negative 7y is negative 14y. And 2 times 4 is 8. Add these together, that gives us negative 22x. 14y minus 14y is eliminated, drops away. 14 plus 8 is 22. So we've got negative 22x is equal to 22. Divide both sides by negative 20, negative 22. Excuse me. Which gives us negative 1. Now I want to plug that back into one of our equations and solve for y. So I got 3x minus 7y is equal to 4. I'll plug negative 1 in for the x. So I got 3 times negative 1 minus 7y is equal to 4. That gives us negative 3 minus 7y is equal to 4. Take the negative 3 over to the right side. We got negative 7y is equal to 4 plus 3. Negative 7y is equal to 7. Divide both sides by negative 7. And we get y is equal to negative 1. So negative 1 will be our answer. Negative 1, negative 1. Okay. Now let's do it on the calculator the easier way. Again, we'll drop our x's, y's, and equals, keep the numbers in their signs. So I got 4, negative 2, negative 2, 3, negative 7, 4. And I go back in my matrix menu, so I do second x and negative 1. Go over to edit, enter on A. It's still 2 by 3, so 2 inner, 3 inner. And I got 4, negative 2, negative 2, 3, negative 7, and 4. Exit out to do a second mode. Now go back to matrix menu, second x and negative 1. Right arrow to math, up arrow to REF. Press enter on it. Go back in matrix menu, do enter on A, enter again. And we get this. Two equations, two variables. Our first 2 by 2 should be a diagonal 1, zeros over else. That's what tells us it worked. And then this will be x, and this will be y. So our answer to this problem is -1, -1. Which we already found with the addition method. Okay, next question. A lot of addition methods here. Now this one's not a calculator-based one. This is strictly by hand. And I'll talk why here after I write it down. So we got x squared plus y squared. Maybe. There. X squared plus y squared is equal to 65. And x squared minus y squared is equal to 33. Now you can't do this one on the calculator. The only time you can solve systems equations on your calculator is when everything's the first power. They're linear. Well, these are the second power. So by hand is the only method that we can use in this. It tells us to use the addition method. Addition method works out well when they look like almost exactly the same. So yeah, these are both x squareds, these are both y squareds, and these are numbers. If this had been an x and y down here, then addition method would probably not be your best bet. Okay, so we're going to add together the equations. X squared plus x squared is 2x squared. Y squared minus y squared drops away. And the idea is to, again, eliminate one of your variables. 65 plus 33 is 98. Yeah, 98. So I got 2x squared is equal to 98. I'll divide both sides by 2. Then we get x squared is equal to 49. On these problems with the nonlinear, you seem to use the square root property a lot. The square root property says whenever you get something squared by itself equal to the other side, you drop your squared, you put a plus or minus square root around the other side. And square root of 49 is 7. Okay, so after we get those, then we want to plug those back in to one of our equations. Doesn't matter which one, whichever one looks easier to you. I'll choose the first one. So we got x squared plus y squared is equal to 65. X we just said was -7, so we got -7 squared plus y squared equals 65. -7 squared is 49 plus y squared is equal to 65. Take 49 over, and you get y squared is equal to 65 minus 49, which gives us 16. Yeah, 16. Now we use square root property again. We got something squared equal to something else, so we'll drop our squared. We'll put a plus or minus square root around the other side. And square root of 16 is 4. So this, from that to x value, we got -7, -4, and -7, +4. Now we also want to do the same thing with this x value. So I got x squared plus y squared is equal to 65. We just said x is 7, so we got 7 squared plus y squared is equal to 65. Now if you square a -7, -7 squared gives you a +49. 7 squared gives you a +49. We're going to find this is going to give us the same y values, so I don't need to go through it. Whenever you have this pattern, the x squareds and the y squareds like this, you never need to solve both of them. You just need to do one of them. Because the other one will give you the exact same y values always. So I got 7, -4, and 7, +4. Probably the tricky part will be entering this in. Type an ordered pair, type exact values in simplified form, use a comma to separate answers as needed. Okay, so I got -7, -7, -4, comma, -7, +4, comma, 7, -4, comma, 7, +4. There's the phone. Next question. Start a new page. And we got 5x minus y is less than 10. This is one that works out pretty nice on the calculator. Maybe not so nice by hand, though. We want to get y by itself on the left side. I'm going to show completely calculator-based here. I showed that system of inequality earlier, and you saw how to do it with the test point and so forth on problem number 1. But I want to get y by itself. So I take the 5x, move it over. So we got negative y is less than negative 5x plus 10. Divide everything by negative 1. And when you do that, it flips your inequality symbol. So we're going to get y is greater than 5x minus 10. Now it's a greater than, so it's going to be look like this. Upper right hand triangle. So let's put this in first. So we'll go to y equals, I press clear, and I will go down to this line, press clear. Now in some calculators it does not clear them out, the inequality over here. So you have to left arrow over and just press enter over and over until you get to your regular slash there, which was right there. And same way here. I think that does that on TI-84C, the color one. Most calculators, when you press clear, it clears that out also. Okay, so we got 5x minus 10. And I want to go over the first slash, and I want a upper right hand triangle. This is the greater than. So press enter twice, and then we press graph. Now this would almost be our answer. Since it's a greater than, this would be a dotted line, but it's not so easy to see where the points fall. So let's go to our table mode on here. So I did second graph. And we want to pick 2 points. 1, negative 5 would be a good one. So let's go over to here and choose my this to enlarge that. And what did I say? 1, negative 5. So choose my line. 1, negative 5. I still can't hardly see it. My eyes aren't very good. And then the next point is 2, 0. So 2, 0 would be a good one, which would be right there. Now this is selected, and I want to make it a dash. So I'll click this make object, selected object dashed, like that. Okay, now if I go back to graph, this left side's shaded. So I want to choose my region shading tool and click the left side like that. And save that. And then next question. Okay, so on this one, I'm going to do it 100% on the calculator. I hate these by hand. If you do them by hand, you have my sympathies. X plus y plus 6z is equal to negative 22. And x plus y, my eyes are bad, plus 7z is equal to negative 26. I need to get new glasses. X minus 2y minus 6z is equal to 32. Assuming I have been able to see the minuses and pluses okay, to do this on the calculator, we're going to write down the matrix goes along with it. We'll drop our x, y, and z's, keep their numbers and their signs. So we got 1, 1, 6, negative 22, 1, 1, 7, negative 26, 1, negative 2, negative 6, 32. Notice how the x's are all in one column, the y's are all in one column, the z's in one column, and the numbers on the other side of the equals are in one column. Well, let's go put this in our calculator now. So I'm going to exit out of there, second mode, and then I'll do my second x to negative 1. I go over to edit, enter on A. Now it's asking us for rows and columns again. This is 3 rows, 4 columns. So I do 3 enter, 4 enter. Then I got 1, 1, 6, negative 22, 1, 1, 7, negative 26. 1, negative 2, negative 6, and 32.
I'm gonna go see Tina.
Okay, have fun.
I haven't heard her. Weather okay? Never.
So I'm going to exit out. It's my wife. She's going to leave me. Better get on match.com now. So let me see. I'll do second, x to negative 1. Go over to math. And go to RREF. Then go back in my matrix menu, enter on A, and enter again. It's a good sign they all came up with those nice numbers. Why is that? They wouldn't have you do one of these by hand if it came up with fractions. It'd be so hideous. Now, 3 equations, 3 variables. Our first 3 by 3 square should be a diagonal of 1, 0, 0 else. That's what tells you it worked. So this will be our x, this will be our y, and this will be our z. So our answer is 4, negative 2, negative 4. So let's go ahead and put that in. 4, negative 2, oops, negative 4. 4, negative 2, negative 4. And next question. Okay, another one. So we got 8x minus y plus 2z is equal to negative 18. And we got x plus 2y minus z is equal to negative 9. We got 2x plus 2y minus 3z is equal to negative 16. Okay, I'm going to drop my x's, y's, and z's, keep the numbers in their signs. So I got 8, negative 1, 2, negative 18, 1, 2, negative 1, negative 9, 2, 2, negative 3, negative 16. And I'm going to go double check my numbers as well as my eyes can tell. Okay, let's go ahead and put that in the calculator. Let's go matrix menu, second, x to negative 1. Go over to edit, enter on A, still a 3 by 4. Then we got 8, negative 1, 2, negative 18, 1, 2, negative 1, negative 9, 2, 2, negative 3. This is the hardest part right here when you're using calculators, actually inputting numbers correctly. So let me go through and double check myself. Okay, that looks good. So do a second mode to exit out. Now I'm going to do my RREF. So do second, x to negative 1, right arrow to math, up arrow to RREF, press enter. Go back in the matrix menu, do enter on A, enter again. And we get negative 3, negative 2, 2. Now 3 equations, 3 variables. Our first 3 by 3 square here should be a diagonal 1, 0, 0 else. That means it worked. And this is our answer. This is x, this is y, and this is z. It's in the same order as your columns. This was x, this is y, and this was z. So our answer will be negative 3, negative 2, and 2. Negative 3, negative 2, and 2. Negative 3, negative 2, and 2. Okay, next question. Solve it by the substitution method. And this one I will show by hand. Those aren't too bad by hand. X plus 3y is equal to negative 2. Then I'll also show it on the calculator. Y is equal to negative 2x minus 24. Substitution method works out best when you're talking about linear systems equations, when one of the equations already solved for one of the variables. This is already solved for y. Now our steps for using the substitution method. First step is solve one of the equations for one of the variables. Well, we'll choose our second equation because it's already solved for y. Step 2. Plug this into your other equation. Our other equation is x plus 3y is equal to negative 2. We just said the y is equal to negative 2x minus 24. So we're going to replace the y here with negative 2x minus 24. So we've got x plus 3 times negative 2x minus 24. 3 times negative 2 gives us negative 6x. 3 times negative 4 is negative 72. X minus 6x is negative 5x. I'll take negative 72 to the right side, so we've got negative 2 plus 72, which gives us 70. And then divide both sides by negative 5, and gives us what does it give us? Negative 14? Yeah. Now step 3 is plug in the value you just found in the equation from step 1, because the equation from step 1 will always be solved for the other variable. We just said x is negative 14, so we're going to have y is equal to negative 2 times negative 14 minus 24. Negative 2 times negative 14 is 28 minus 24, or y is equal to 4. So that gives us negative 14 and 4. To do this on the calculator, you have to have all the variable terms on the left side. So I need to take this negative 2x and move it over to the left side on the second equation. So we're going to have x plus 3y is equal to negative 2. Take negative 2x over, it becomes a positive 2x, plus y is equal to negative 24. Now notice that the x's have to be lined up, the y's have to be lined up, and the numbers have to be lined up. Now at that point, we'll drop our x's, y's, and equals, keep the numbers in their signs. So we've got 1, 3, negative 2, 2, 1, negative 24. Okay, so I'm going to go to my matrix menu, do second x negative 1, go over to edit, do inner on A. So 2 by 3, so I do 2 inner, 3 inner, rows by columns. And I got 1, 3, negative 2, 2, 1, negative 24. Exit out, so I do second mode. I'll go do my RAF, so I do my second x negative 1, go into math, go into RAF, go back in matrix menu, choose A, enter again. And I got negative 14 and 4. Two equations, two variables. Our first 2 by 2 square here should be a diagonal 1 zeros over else, which it is. That means it worked. This is x and this is y. So our answer will be negative 14, 4. Okay, I'll go to the next question. Let me grab a drink here. And we got x squared plus y squared is greater than or equal to 9. Now the only time it's really a calculator-based question is when you can get y by itself easily. I could probably get y by itself here, but I'd have to use square root property. I don't even know how the square root property applies to inequality, and I definitely wouldn't know how to enter it into the calculator. This is a by hand one. Whenever you have x squared plus y squared, that's always a circle with the center at the origin. And your radius is given by this number. You take square root of whatever that number is, so r is equal to square root of 9, or r is equal to 3. So, center's at the origin, right here. Radius is 3, and it's a greater than or equal to that. Line underneath means it's be a solid line. So go around like this. Now, greater than means you shade outside the circle. So that'd be our answer there. Let's figure out how in the world to put that in the calculator, though. Or calculator, in my math lab. I want a circle tool, I'm assuming. Here's a circle tool. Click the graph to plot the center of your circle. Okay, so go to center. Then I'm assuming go out to 3. Right there. We said this was a solid line, so otherwise I'd use this dash to make it dashed. I need my region shading tool, so I click that and click outside. And click save. It looks much prettier than mine. And next question. And it says solve the system by the substitution method. So we got x plus y is equal to 5. And we got y is equal to x squared minus 7. Now this would not be, you can't do this with the REF. And the reason why is because not everything's the first power. We got squared in there. Only time you can use REF is when you're solving a system of equations, everything's the first power. So this one you have to use either the addition method or substitution method. And they tell us, they're telling us to use the substitution method. Now this is already set up such as this is solved for y, but I'm going to follow my steps. My first step says to solve the equation with the smallest powers for the variable with the smallest power. Well, the equation with the smallest power is x plus y is equal to 5. Now both of these are to the first power, so it doesn't matter which one I solve it for. I'm going to solve it for y. So I take the x over, and we get y is equal to 5 minus x. Step 2. Plug this into your other equation. Our other equation is y is equal to x squared minus 7. Now here we just said the y is equal to 5 minus x, so we're going to place the y here with 5 minus x. So we got 5 minus x is equal to x squared minus 7. And then we want to solve this. Well, this is a quadratic, so I want to get everything over one side. So I'll take negative x over and take 5 over. So we got x squared. The negative x becomes a positive x. Minus 7, take the 5 over and becomes a negative 5. Which gives us x squared plus x minus 12. Now this factors using the PSD method. So this will factor as x plus 4 times x minus 3. Now the zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x plus 4 is equal to 0, and I'll set x minus 3 equal to 0. And that gives us x equals negative 4, and x is equal to positive 3. Now step 3, we want to plug those values into the equation from step 1. The equation from step 1 will always be solved for the other variable. So we're going to plug those into y is equal to 5 minus x. Well, we just said that x is negative 4, so we've got 5 minus a negative 4. Negative negative becomes positive, so 5 plus 4 is 9. So this answer will be negative 4, 9. Now this one, we'll plug that in. So we got 5 minus 3, or y is equal to 2. So this answer would be 3, 2. And those would be our two answers. Okay, so let's plug those in. I got negative 4, 9. Sure don't plan these for the people who can't see very well. Should be some way to make this larger. Original size. Oh well. Let me click submit test to see how many I missed. Perfect. I like that. I like to see that. Let's see. Go to results. Okay, that's Chapter 5 test review.